You know, whenever you're building a new piece of software, you face this huge choice right at the very beginning. Do you build it as one solid single block or as a bunch of interconnected little pieces? This one decision, it can be the difference between an app that soars to millions of users or one that just completely collapses under its own weight. So today, we're going to break down that exact choice, monolithic versus distributed systems. And really, it all boils down to this one simple question, right? Should you build your application as one massive, self-contained unit? Or should you break it up into a whole collection of smaller, independent services that all work together? It's a classic puzzle in software design, and we're going to explore all the trade-offs of each way of thinking. All right, first up, let's talk about the traditional way of doing things. This is the monolithic approach. You can kind of think of it as the original recipe for building software, an all-in-one powerhouse where absolutely everything is connected. So what exactly do we mean by monolithic? Well, it's pretty much what it sounds like. It's a single, unified application built as one big unit. Just imagine one giant block of code where your user interface, all the complex business rules, and even the code that talks to your database, it's all bundled together. The entire system is developed, deployed, and runs as one single thing. Now, there's a really good reason monoliths are so popular, especially when you're just starting a new project. They are super straightforward. You can get a simple app up and running incredibly fast. And for a small team, it's just way easier to get your head around one single code base. It's often the perfect choice for a startup's first product, or if you just need to whip up a quick prototype. But, and this is a big but, here's the catch, that initial simplicity, it can come with some serious headaches down the road. Let's say just one tiny feature of your app suddenly gets a ton of traffic. With a monolith, you can't just scale up that one part. No, you have to scale the entire application. It's all or nothing. And what's worse, a single bug in some non-critical feature can bring the whole system crashing down. It's a single point of failure. So to try and solve some of those big problems with the monolith, a totally different philosophy came along, the distributed approach. This method is all about building a system with, well, power in numbers. A distributed system is basically the polar opposite of a monolith. Instead of one big unit, your application is broken down into a whole set of smaller, independent services. Each one of these services handles a very specific job and runs on its own. They all communicate with each other over a network to get things done. It's kind of like having a team of highly trained specialists instead of just one person trying to do everything. And the absolute best example of this in the real world? Netflix. I mean, think about it. When you press play on a movie, you're not connecting to one single giant Netflix computer somewhere. No way. You're actually connecting to a massive worldwide network of thousands of specialized servers. Some handle your login, others are busy finding the movie you picked, and a whole different set is just focused on streaming that video to you smoothly. It's this distributed magic that lets millions of people watch at the exact same time without a hitch. And that right there, that brings us to the huge advantages. Need to handle more people streaming video? You just add more streaming servers. The login service? It's completely untouched. That's what we mean by scalability. And it's incredibly fault tolerant. If one of those thousands of servers fails, others just seamlessly take over. The system basically heals itself. And most importantly, your movie night isn't ruined. Of course, all of that amazing power comes with a price. And that price is complexity. I mean, designing, deploying, and managing hundreds or even thousands of services is a massive challenge. You're suddenly fighting things like network lag. You have to make sure your data stays consistent across services that might be in different cities. And just trying to track down a bug when it could be happening in any one of those dozens of moving parts, it is a whole different ballgame. Okay, I know that was a lot of technical stuff. So to make this really stick, let's use a simple, everyday analogy that I think everyone can get behind. Let's talk restaurants. The monolithic system? That's like your favorite small local restaurant. You've got one chef in one kitchen, and that one person is preparing every single dish, from the appetizers all the way to the desserts. It's simple, it's efficient, especially on a small scale. Now, the distributed system, on the other hand, is like a global fast food chain. You've got thousands of individual restaurants, each one handling orders for its local area, but they all work together under one big brand to serve a massive, massive number of customers. So, after all that, the big question is, how do you actually choose? Which path is right for you? Well, it turns out the answer depends entirely on what you're trying to build and where you think it's going to go. Here's a good rule of thumb. If you're a startup, or you're building what we call a minimum viable product, an MVP, you should probably start with a monolith. Your number one goal is speed and simplicity. You just need to get it launched. But if you're building the next Netflix or the next Amazon, an application that's designed for millions of users from day one, then you absolutely need the kind of scalability and reliability that only a distributed system can give you. So, at the end of the day, it all just boils down to this one core trade-off. It's a fundamental choice. Are you optimizing for the simplicity and speed you get with a monolith, or do you need the raw power and incredible scale of a distributed system? That's really the question you have to answer.
But what if you could get the best of both worlds? What if there was a way to structure a system that gave you all that power without the crushing complexity? Is the choice really just between one giant block and thousands of tiny little pieces? Well, that's a question we'll explore next time. Thanks for joining this explainer.